Good evening everyone. Myself Gautam Sarma. I welcome you all in a Sapiens Education. So today I am going to discuss about the total internal topic. This is the part 4th video of the tree optics. So I am also going to discuss about its application. See, when you observe this type of figure, so let us consider this type of figure. So these are the figure when a light passes from denser to rarer medium. So as you know that this is your denser medium, water is your denser medium, and air is your rarer medium. So whenever a light will pass through denser to rarer medium, so what will happen? A light will always bend away from the normal. So by this principle, we will understand what actually happens in the total internal reflection. Now let us draw. First of all, let us draw the interface so that you can understand here. So let us. This is an interface. This is an interface, right? This is an interface, and this is a rarer medium, and this is a denser medium. Now let us consider there is an object which is kept in a denser medium, and when a light will start incident on the interface, so what will happen? As it is perpendicular, so light will pass thoroughly. Now let us consider if we change the angle of the light, of the angle of incidence. Here the angle of incidence was 0 degree. Now when you increase the angle from 0 to somewhat angle, so what you observe? Let us consider this is a normal and this is an angle theta 1. So due to which what happens, a light will bend away from the normal. Now as you increase more angle, so what you have observed? So let us consider this is an angle, and at this incidence points, what you will find, it will bend in this direction. Okay, so let us consider this angle is considered as a angle C, and this angle is considered as a 90 degree. So the angle C is known as critical angle. Angle C is known as critical angle, right? Now as why it is considered as a critical angle, or what is critical angle? The angle for which whenever light passes from denser medium to rarer medium, whenever a light is passed from denser medium to rarer medium, the angle for which the angle of incidence for which the angle of reflection become 90 degree when it passes from denser medium to rarer medium, so that angle is called as critical angle. As soon as you increase this angle little bit more, so what will happen? So let us consider this is an angle. So if we increase it more, so what will happen? Let us consider if we increase it more, so what will happen? So this is theta 2. So what we have observed, that it will also bend more away from the normal. So suddenly it has been observed that this incident angle, and this is a reflected ray. So suddenly what happened, light bend more away from the normal when it passes from denser medium to rarer medium. Suddenly its angle starts increasing. As soon as it increases greater than the critical angle, so what happened, we have observed that there is a total internal reflection happens. Okay, so whenever a fall incident light is greater than the critical angle, then we will observe that whenever a light will fall at an angle greater than the incident angle, then what we will observe that there is a total internal reflection will happen. Earlier what you have observed, that there is a refraction only. But when you observe this one, so it will be total internal reflection. So this phenomena is known as total internal reflection. Now we can go do for, some of the derivation, as we know that let us consider this is your mu 2 and this is mu 1. So what we can say that mu 2 into sine c is equal to mu 1 sine 90 degree. So sine 90 degree is your 1. So what you will observe that sine c is equal to mu 1 by mu 2, or we can say that it can also be considered as it can be also considered as 1 by mu 2 with respect to 1, and this is equal to sine c and angle c. If you want to find a critical angle of any of the interface with respect to the other, so we can directly find like the sine inverse 1 by mu 2 to the power 1. Okay, so this is called as critical angle. This is known as critical angle. Okay, so when we observe that we have observed that practically it has been observed that if glass, let us consider this is a glass. So the refractive index of glass is 1.5, critical angle is 42 degree. The refractive index of diamond is 2.4, critical angle is 24 degrees. So critical angle is inversely proportional to the refractive index. Okay, critical angle is inversely proportional to the refractive index. So I hope you have understood this concept. Now let us go for next topic, that is diamond. Let us consider this is a diamond. So what happens in a diamond? So before that, what we have observed now that critical angle is inversely proportional to the refractive index, right? Okay. Now let us take two refractive index. This is considered as less refractive index values, and this is considered as more refractive index. More refractive index. So now let us consider this is a normal. Now let us consider this is a normal, and less refractive index means more critical angle. So let us consider this is a critical angle. This is your critical angle, and more refractive index means less critical angle. It will have a less critical angle, so this is considered as also critical angle for this. Now when a light will pass, let us consider each and every degree. For each and every degree, how much? 90 degree, there is 90 degrees. So for each and every incident light, so there are 90 rays of light. So when you observe that there are lots of critical angle is more, so what we have observed that till this we have got the refracted ray as let us consider critical angle. Let us consider we have got a refracted ray as 60, and reflected ray we are getting here as 30 number of refracted ray. But when we have a more refractive index, that is less critical angle, so what you will observe, we will observe that there is a less number of light will fall which will be reflected. So let us consider this will be reflected only 30, so rest will come down like this. Got it? So let us consider 60. So more total internal reflection happens. more TIR happens in this, and in this less TIR happens. Okay, so I hope you have understood. So more refractive index, more TIR will happen. So as you know that when we talk about the diamond, let us consider this is a diamond, right? So in diamond, what happens? Light will fall like this. So what will happen? It is its refractive index, and it's designed in such a way that it when it passes inside, so again it will be denser medium and it is rarer medium. So when it passes through denser to rarer medium, so it is less than the it is more than the critical angle. So what happens, it again reflect back in the same medium in certain angle. Again from this layer also it again refract back in the same medium like this. So there will be a lot of time, there will be a total internal reflection, and maybe it will get one time where its angle will be less than the critical angle. So what will happen, a light will come out from this. So you can understand that the light will remain in this diamond. We can observe that light will remain longer time in the diamond, right? So when light will remain in a longer time in a diamond, so what will happen, it will starts glowing more, it will glow more. So this is known as brilliance of the diamond's brightness. Okay, glow more. So first thing is that light total internal happens for multiple times due to its structure. So when you observe its structure, see here, when you observe its structure, so it has been cut in certain angle. Due to angle, what happened? Lots of multiple total internal reflection happens. Multiple times total internal reflection happens. First of all, you have to understand this. And second, when we talk about the refractive index, so due to high refractive index of a diamond, high refractive index of diamond, what we have observed, diamond, what we have observed, total internal number of total internal reflection, number of TIR happens out of diamond, number of total internal reflection happens out of diamond, number of total internal reflection happens out of diamond is more, and hence it will and hence it will glow more. So this is what the application of the total internal reflection for the diamond. Now let us go for mirage. You know that mirage, we will discuss about the mirage here. Let us consider this is an object. Let us consider this is an object, okay? And we know that in a hot days, there are lots of hot days. What happens? The ground will become very much warm. So which what will happen? Lower layer will be warmer and upper layer will be cooler. Okay. Now let us consider a light is going from denser to rarer. Why? Because upper layer is cool and lower layer is hot. So hot air means lesser denser, and cold air means more denser. So when a light passes with the layers, so what happen, light will bend away from normal, again away from normal. But at a certain point, what will happen, it will if the angle of incidence is greater than the critical angle. See, this is a greater than the critical angle. So what will happen, there will be a total internal reflection happens. there will be a total internal reflection happen. See here, there will be a total internal reflection. Just you try to understand from this figure also that there is a lots of layers of air. Okay, layers of air, right? So these are the layers of air. Okay, so these are the layers of air, and this is the object. So what will happen when light will come like this? So what will happen? First, light will bend away from normal like this, again away from normal like this, but at this point it is greater than the critical angle, so it will go to the same medium like this, as it is going from, that is going from denser to rarer medium, so it will go like this. So when this incident light will fall on the eye of the observer, so observer will think that the light is coming from backside like this. So that's why the image of this object will be seen below, and this is known as total internal reflection, and due to which total internal reflection, mirage effect happens. So when you walk or when you go by bus or anywhere, and you will find that there is a sky image of the sky, image of the tree will be seen in the hot days, but actually there is no water, but there is an illusion effect of the water. And this can also be observed in the desert also, there is an illusion effect. You know that in desert, when you go and you will think that there is a water at that far away distance, but when you reach there you won't find water. So this illusion is known as mirage effect. So I hope you have understood this. Now one more important thing is that refractive index. Let us consider this is a triangular lens, triangular prism you can also observe. And when a light will incident like this, so what will happen? It's greater than the critical angle, right? See, when it will be greater than the critical angle, so it will bend at the same degree. So when it will bend to the same degree, so what will happen? This P will be like this, and Q, that Q sorry q p dash, so this is a p dash, so you will find there is a formation of p dash. So let us consider there is an object like this, so you will find then object is like this. So this object's image, so that definitely this was an object, and its image turned to be 90 degrees. So if you want to turn any image 90 degrees, so you have to use this structure. Okay, so again I will show you another structure. This is structure. If we want you want image to be turned around of 180 degree, let us consider this is an image qp, and its a light is going like this. So again it is greater than the critical angle, so again it goes like this. A light going like this, so again it is greater than the critical angle, so it is again like this. So again coming like this, right? So light is going like this. So finally we are getting a p at this side and q as this sign. So whenever you want to create an image which should be a 180 degree inverted, so you can use this type of structure. So this is 90 degree length, 90 degree, this is 45 degree. So I hope you have understood this. Now let us go for a next application, that is known as optical fiber application, right? Optical fiber, you have seen that in our homes there is a 5G network or 4G network, any network. So that network where we transfer a data, internet and all. So what happens? We uses generally optical fiber has been used, so that is speed of the data transfer can be increased. So what is the application of the optical fiber? See here the same application has been used. Let us consider a light is incident on this. So this layer is a denser layer, and above layer is your rarer. So whenever light passes through the denser to rarer, so it is a greater than the critical angle, so again it will turn like this. So in this way there will be a lot of transfer of the light without losing of energy. So when you actually observe this, so what happens? See, this is what happens. So this is a light signal, so signal has been transmitted like this. See here, signal has been transmitted like this. So what will happen? It will pass like this. So whenever even you bend this type of wire, then also it will pass thoroughly without any losing of energy. And why without any loss of energy? Because it is total internal reflection. Whatever you are giving the energy, so it has not been observed by this layer, so totally there will be a reflection happens. So this phenomena is known as total internal reflection, and this is an application. This is an application. Optical fiber is an application for this. Optical fiber is an application for optical fiber is an application for total internal reflection, right? I hope you have understood this. So I am closing this session for this topic. I will again come up with the next topic. Thank you for watching my video.